Hello, my amazing students. This is Mrs. A, and I love math. And today we're on lesson 68 in our Saxon Orange book, and we're talking about more about complex fractions. So, the first thing we need to talk about in this lesson is what is a rational number? Well, a rational number is a number that is a ratio. Ratio is the root word of rational, and it is the ratio of two integer values, two integer numbers, and that is what a rational number is. So 13 is a rational number because we could write that as 13 divided by 1. 4/7, -5/14, -6/13, and also mixed numbers, 2 and 1/3, are all rational numbers. So then we need to discuss what is a rational expression. A rational expression is two expressions, algebraic expressions, written in a fraction form, one over the other. So x plus y over 4, a over -b plus c, 5, and -7 over x. So when you say, well, 5 is a rational number, but all rational numbers are also rational expressions. So basically a more complicated definition of rational expression would be a polynomial divided by another polynomial. And we know that a polynomial could be a single-termed constant, could be a polynomial, because poly just means many, and nomial just means terms. And so many terms is a polynomial. And here we have two terms, and here we have two terms, but then we have one term on the bottom and one term on the top, but they're all polynomials divided by polynomials, therefore they are rational expressions. So here we say a rational number is also a rational expression. Now, one thing that we're not going to deal with in this section is the whole idea about the denominator being 0. We know that on fractions the denominator can never be equal to 0. And on rational numbers, which are basically fractions made out of polynomials, they cannot be denominators of 0 either. Therefore, since it's just a big no-no, we're just not even going to worry about discussing it in this chapter. We're just going to say, okay, fractions do not have 0 denominators, and rational expressions do not have 0 denominators, and so we're just going to leave it like that for the purposes of this book's chapter 68 discussion. Okay, so now we're going to talk about to add or subtract two rational expressions, we must have a common denominator. If we're adding or subtracting regular fractions, don't we need a common denominator? Well, we're going to treat rational expressions very much the same way we treat rational numbers, which are fractions. So here we have a problem. We're going to add a over b plus x over y. The first thing we need to do is get a common denominator. Since b and y have no factors in common, the common denominator would be the product by. So we know that this has got to turn into by, and this has got to turn into by, but we can always multiply by the same thing in the numerator and the denominator. That is a must. So since this is a b going to a by, we multiplied it by a y. We must also multiply the a by a y and get a y. And since we multiplied the y by a b to get by, we will also have to multiply the x by a b to get bx. Now the last step is to combine them over one denominator. So ay and bx have nothing in common, so we cannot put them together, but we're going to put them as a sum over by, and there's our answer. Okay, so when we're looking at a division problem, we can also use the multiplying by the same thing to simplify a division of two rational expressions, which is called a complex fraction. We have a fraction that has fractions inside it, or fractions within fractions. They're called complex fractions. In order to simplify them, they do look kind of beastly, don't they? In order to simplify them, we always want to multiply by the reciprocal of the denominator. So we're going to take b over c and multiply it by c over b. But if we multiply this one by c over b, we're going to multiply this one also by c over b. Well, b over c times c over b just goes to 1. And now we've changed our division problem into a multiplication problem. Does that look familiar? When we divide by a fraction, don't we instead multiply by the reciprocal? Isn't that what you've always learned? You just didn't know that it was because of this, did you? All right, so it is because we're multiplying the numerator and denominator by the same quantity that makes the denominator go to 1, which is the reciprocal of the denominator, that we end up getting the division by a fraction equals the multiplication by its reciprocal, which you've been knowing for quite some time. Now you know the reason why it's so. Okay, so now we have this, which we can just simplify xc over yb. What fun is that? There we go. Here I have another problem. Okay, now this one looks very complicated, but if we take it little bit by little bit, it's not so bad. Now, if we just look at the numerator for a minute, okay, then could we add those two together? And if we did, since they have the same denominator, we could add them together. I'm going to actually do this problem two ways for you. And we would get x plus 1 over y divided by, now these have the same denominator. So couldn't I say that this is x minus 1 over y? All right, so now could I look at this as a fraction divided by a fraction, which means that when I divide by a fraction, because of what I just showed you, I multiply by its reciprocal, and it's the same thing. All right, now I could come over here and I could do multiply, and I could take what is the reciprocal of this one and multiply both the top and the bottom by that same number. The reciprocal of the denominator is y over x minus 1, isn't it? Well, y over x minus 1 will make these two go away. So then I'm going to wind up with x plus 1 over y times the reciprocal of the denominator, which is y over x minus 1. So now to finish up, will my y cancel my y? And I wind up with x plus 1 over x minus 1, and that is the answer. And I'm going to do it one more way. So starting back here, if we added these two together and got x plus 1 over y and x minus 1 over y, and then we multiplied by the reciprocal, which is what I told you about last time. And then we're going to multiply this one by the same thing, because we always multiply by 1 or we change things. Okay, so now I've multiplied by the same thing over itself. Therefore, I just multiplied by 1. That's not going to change anything, but it makes this one go to 1. And now we're just multiplying these together. The y's will cancel, and we get x plus 1 over x minus 1. Now, I'm going to show you one last way to do it. It's always fun to know several ways to do things. Okay, I'm going to go right back up here. Okay, now remember, this is an x minus 1 over y, and this is an x plus 1 over y. It's kind of messy. What if I just multiply both the top and the bottom by y? What if I multiply times y over 1 over y over 1? What happens? The y cancels the y cancels the y, and I multiply and I get x plus 1 over x minus 1. That's the cool thing about math. As long as we are using correct principles, we will get the same answer even if we do a problem several different ways. Okay, now this is example 68-2, and I have a little problem. I'm going to do this one two ways also, okay? The first way I'm going to do it is I'm going to say, I got this rational expression, but this part's giving me trouble. I'm just going to get a common denominator and add these two things together and then worry about the 7. That's a valid way to do it. So I'm going to say, well, let's just change the 1. Since I need an x on the bottom to match this x, so I have a common denominator, I'm going to make this 1 into an x over x plus a 1 over x, and then I'll deal with this 7 in a minute. All right, well, x and x, common denominator, so I add the numerators together and I get x plus 1 over x divided by 7. Okay, now we've already talked about division by a fraction. What if I just make that 7 over 1? Can I do that? And then I know that division by a fraction is the same as multiplication by its reciprocal. Well, 1 over 7, 1 over 7, this goes to 1, and I end up with x plus 1 times 1 over 7 times x. That looks pretty simplified to me. Now, we're going to leave that answer there, but we're going to go do the problem an entirely different way, okay? So instead of doing what we did there, I'm going to say, I don't like that x on the denominator. I'm going to, right off the bat, multiply by the least common denominator. This one has a denominator of x, this one has a denominator of 1, and this one has a denominator of 1. So my least common denominator would be x. So I'm going to multiply everything by x. If I multiply 1 by x, I get an x. If I multiply 1 over x by x, I get a 1. If I multiply 7 by x, I get a 7x. Do I have the same thing I did the first time? X plus 1 over 7x. I got the exact same answer just by multiplying everything, the numerator and the denominator, by x. That's pretty fun. Okay, so here we have another problem. This is example 3 in your book, 68.3. All right, now let's think about this. I have that 1 over x again. So we just, in the last problem, we said, you know what? A fast way to do this is to multiply both the numerator and the denominator by the least common denominator of all of them. Let's see if it works here. So this one has a denominator of x, this one has a denominator of x, this one has a denominator of 1. So the least common denominator between all of them would be x. So I'm just going to check and see if that little step will work. So I'm going to multiply by x and x. All right, now just to make it a little bit easier, I'm going to make it x over 1 times x over 1. It's the same thing, right? I'm just turning it into a fraction with 1 as the denominator. So x over x is the same thing as x over 1 divided by x over 1. Now, let's multiply. 1 over x times x over 1. Isn't that the reciprocal of this one? Don't I just get 1? So I'm going to get 1 over 1 times dx is just going to give me an x minus 1 over x times x over 1 reciprocals. So we end up with 1 over x minus 1. That looks pretty nice. Now, that was a really easy way to do it. Let's do it a little bit harder way by getting a common denominator first. Okay, so we're going to do it the same way, but just a little bit kind of what they're teaching you in the book here. It's right. It's just not always the easiest way to do it. Okay, so let's do this one. Let's get a common denominator. So 1 would be x over x. Let's put an equal sign. So we're going to make this x over x minus 1 over x. And then up here we have 1 over x. Now, since these have the same denominator, can I put them together? Which means that I'm going to, now this was my old answer, I'm just leaving it there, okay? Which means that I'm going to get 1 over x divided by, and now that I have the same denominator, can I say x minus 1 over x? Okay, so if I got right there, could I multiply the top and the bottom by x and be done? If I multiply the top and the bottom by x, the same thing on both the top and the bottom, it's okay. I would end up with x over 1, x over 1. I'd end up with 1 over, my x's would cancel, x minus 1. I'd get there right away. Okay, but instead of that, we're going to multiply by 1 in the form of the reciprocal of the denominator, because that's what your section is teaching you how to do. What I'm trying to teach you is that there's more than one way to do the problem. And sometimes multiplying by x over x is going to get you there faster than multiplying by reciprocal over reciprocal. Okay? So, here, I'm doing it the way the book tells you to do it. I'm going to multiply by 1 in the form of the reciprocal of the denominator. So that's going to be x over x minus 1, x over x minus 1. And what I'm trying to show you is that you will still get this answer. We've done it 3 ways now. And you're going to get this answer every way. As long as you're following mathematical principles, you will get the same answer. All right, so now, doesn't this one go to 1 on the bottom? So now we're just multiplying these two together, but look at that, the x's cancel. We get 1 divided by x minus 1. The third time, we get the same answer. Okay, so now, I'm looking at a problem. This is example number 4. A over b plus 1 divided by x over b plus 4. Now, we've discussed several different ways to do this. They're all legitimate ways to do it because they're all involving mathematical principles. If I just wanted to look at all of the denominators, then wouldn't b be the least common denominator? I can always multiply the numerator and denominator by a constant. And this, even though it's a variable, we can treat it like a constant, okay, by a single non-zero term. So, what if I, first way I'm going to do it, multiply by the least common denominator of all the denominators, and I'm going to say, all right, I'm going to multiply by b over 1 and b over 1. Let's see what it does. Okay, a over b times b over 1. Well, b's on the bottom, b's on the top, won't they cancel? And I'll end up with a plus 1 times b is b over, now x over b times b over 1. The b's are going to cancel and I'm going to get x plus, now I'm multiplying 4 times b and I'm going to get 4b. Okay, That's one way to work the problem. That's not the way your book is telling you this section, but I get a good answer. Okay, so now we're going to leave that answer there, and we're going to change the way we work the problem. Okay, so I call that one the multiplying by the least common denominator method. Now we're going to get this over one denominator and get this over one denominator, and then do the multiplication by the reciprocal, which is the one the book is teaching you this time. All right, so don't I have a problem? Isn't this one going to actually, when I rewrite it, be A over B plus, I need a B on the bottom, so wouldn't that be B over B? And then I'm going to divide by X over B. And then I want a B on the bottom again, so I can add these together. So what if I multiply the top and the bottom, 4 over 1, right, by B over B, and get 4B over B. So now I'm going to write this as one term, A plus B over B divided by X plus 4B over B. Okay? Now, I'm not going to do it this time because I'm going to boil it down to 2 times instead of 3 times. But can you see that right now, if I just multiplied the top and the bottom by B, just B, I would go up to that answer. Right now, I could just basically get rid of those B's, because if I multiply that by B, I get A plus B. I multiply this by B, I get X plus 4B. Goes right there. Okay, but I'm going to do it the book's method. I'm going to say, okay, I'm going to multiply by this reciprocal. So the reciprocal of this is going to be B over X plus 4B. And then I multiply by the same thing on the top. And it's going to be B over X plus 4B. Okay, so now I multiplied by the reciprocal of the denominator, but I multiplied by the same thing on the top and the bottom. That goes to 1. A number times its reciprocal is 1. Now I'm just multiplying this together, but my B's are going to cancel. A plus B over X plus 4B, back there again. 3 different ways to work these problems. Okay, now notice that in this case, just multiplying every term by the least common denominator was the fastest way to work the problem, wasn't it? And every time we did it, we got the same answer. Okay, so this is the last example before we start our practice problems. Look what they have, negative exponents. A to the negative 1 is 1 over A, isn't it? So we have 1 over A times X. Well, since it's times X, doesn't the X come up here? All right, so plus B to the negative 1 would be 1 over B times Y, means that a Y is going to go up here. Now we look at the denominator. X to the negative 1 is just 1 over X. Now, what a mess. But what we can do is multiply through by the, we could do this 3 ways like we did the last one. I'm going to show you we're going to get the same answer all 3 ways. Okay? So, what would be the least common denominator of an A and a B and an X? When the least common denominator be ABX, it's the least common multiple, isn't it? So what would happen if I multiplied by ABX over ABX? Did I multiply both the numerator and denominator by the same quantity? I'm using my least common denominator method here, okay? So now, x over a times abx. Won't the a and the a cancel? So wouldn't I get bx squared? Okay, and then the a would be gone. So now I'm going to do the same thing with this one. Plus, now y over b times abx. Okay, so that won't the b's cancel? And I'll get a y a x. Okay, now let's look at the bottom. 1 over x times, now remember we could put a 1 under there if we wanted to. 1 over x times abx. The x and the x will cancel, so I'm just going to get ab down there. Okay, now that ab is not going to cancel with anything. Now, this is a correct answer right here, like it is. But since we have an x and an x squared, what your book does is they pull an x to the front and they write it as x times bx plus ya, because we pulled the x out, divided by ab. That is the answer that your book is giving you. And we got there just by multiplying both the top and the bottom by abx, the product, abx. But now, let's do the same problem the way the book is telling you to. So I'm going to leave this answer here. And we're going to go the other process because I want you to have lots of tools in your box. Okay, so now I erased this part. This part right here was just this written correctly. Okay, so now instead of doing what I just did, which was multiply by abx on both the top and the bottom, I'm going to just multiply by the reciprocal of the denominator. So we're going to multiply by x over 1 divided by x over 1. So now won't this cancel because it's a number times its reciprocal? And now, am I not just going to multiply everything through by an x? So I'm going to end up with x squared over a, because this is x over 1, plus y x over b. But I don't have these put together. So what if I say, well, I got an a here and a b here. What if I multiply this one over here by b over b, and I multiply this one over here by a over a, and then, because I have a BA and a BA, can't I take all of this and put it over just one denominator, BA or AB? Okay, so now bx squared plus yxa over ab. Now, because I have an x and an x, your book leaves it with the x pulled out front. Okay, so that's just an x in the front, pulled out, factored out. If I factor out an x, I get a bx. If I factor out an x, I get an ay. And divide by ab, same answer. Okay, now here's your first practice problem. I'm hoping that you'll pause your video and go do these yourself so that you don't have any problems when you get to the lesson. Now, I'm going to do this the way the book wants you to, the way that your book has taught you how to do them this lesson, because these are your practice problems, okay? So since these are already the same denominator, can I put the numerators together and say 1 plus c over w divided by 1 over c, and then we're multiplying by the reciprocal in the form of 1, right? So I'm going to multiply the reciprocal of the denominator is c over 1, c over 1, c over 1. I'm multiplying this by that, okay? So now let's see what happens. This goes to 1, and I end up with c plus c squared. But see how they already have it factored out? And they really don't want us to have the c plus the c squared. They'd rather us have c times 1 plus c over w times 1 is w. That's how you would probably find this answer in the book. Okay? Now, what if I went back here and I multiplied everything by the least common denominator? What if I multiplied everything by WC? Okay, so I'm just going to multiply this WC over WC. I'll do it over here because I don't want to erase all of that. Okay, so now let's check. What is WC times 1 over W? Well, the W's will cancel, and I'll just get C. Okay, so we'd get C plus, and then WC times C over W. The W's would cancel, but then the C would be C squared. And then WC times 1 over C, the C's will cancel, and I'll get a W. All right, now, I have an answer. It was pretty easy to get. Now, what's going to happen if since I got a C and a C squared, can I just factor out the C? And then wouldn't I get a 1 plus a C over W? Back to what I got when I did it the book's way. Okay, so we're going to do this the book's way, which is multiplying by the reciprocal. But first, I need to get these put together. Well, that's not too hard because they're already an M and an M. So we're going to have 2 minus x over M. Okay, and then I'm going to go ahead and put these together. But this one is 5 over 1. So to put them together into one term, I need to make that an M. So I'm going to multiply by an M on the top and the bottom. And I'm going to get 1 plus 5M over M. So now I have a single term. This is a complex fraction now, right? So now, can you see, one way to do it would be to just multiply the top and the bottom by M, and I would have 1 plus 5M over 2 minus x, which is the answer. But I'm going to do it the way the book says. I'm going to multiply by the reciprocal in the form of 1. Okay, so I'm going to have 1 plus 5M over M divided by 2 minus x over M times the reciprocal of the denominator, which is M over 2 minus x, M over 2 minus x. Okay, and then this is going to cancel. And then look what happens. My M on the top and my M on the bottom cancels. And I end up with 1 plus 5M divided by 2 minus x, which is what I got before. Did you get the same answer? All right, so here we have one with negative exponents. This is your last practice problem for this lesson. So we're going to write this one. Remember, x to the negative 1 is 1 over x. So a times 1 over x would be a over x plus. Now b is going to go on top, but the y to the negative 1 is going to go downstairs. 1 over y times b is b over y divided by x to the negative 1. Well, x to the negative 1 is 1 over x. Okay, so if I were going to do it a really, really quick way, could I look and say, oh, I have a denominator, x, y, x, the common denominator. If we're going to get a common denominator, it would be xy. If we multiplied by xy over xy, using the least common denominator method, what would we get? We're still multiplying by the same thing on the top and the bottom. Okay, so if I multiply this by xy, then I would get what? The x's would cancel and I would get ay. If I multiply this by xy, the y's would cancel and I'd get bx. And if I multiply this by xy, the x's would cancel and I'd just get y. So there's our answer. But We're going to do it the way the book tells us to, which means we're going to go back here and we're going to multiply instead of xy, which works. We're going to multiply by x over 1 over x over 1, which is also going to work. Okay, so now, since we multiplied by the same thing, these are going to go to 1. So we can just poof, they're gone. So now what's going to happen? A over x times x. So basically this whole thing is multiplied by x now. A over x times x is going to be a. And then b over y times x is going to be bx over y. Okay, now the problem is this is not all put together in one term, right? But what if we wanted to make this one term? Then we would need to make this a y on the bottom, which means we're going to multiply by a y over y. And now we have the same y, which means I can add these together and put them all over 1y, and guess what I get? ay plus bx over y. And I hope that you have learned that math principles are really, really cool, and that the way in which you do a problem is very flexible as long as you use the proper principles. And the principle that you were using, your book has a very interesting name for this principle. It is the denominator numerator same quantity rule, which simply means that we're going to multiply the numerator and the denominator by the same thing. And that's what we did. Even though I chose several different ways to multiply it, I was always multiplying by 1, which meant the numerator and denominator were multiplied either by least common multiple, or they were multiplied by a reciprocal of the denominator, or they may have just been multiplied by the common denominator of all of them, which was sometimes just an x, and that made it fall out really easily. So I hope you've enjoyed this math lesson. This has been a fun one for me to teach you. And this is Mrs. A, and may God bless your day.